Welcome to Spexi's Drone Safety and Best Practices course. This course covers the basics of flight preparation, as well as preparing yourself, your drone, and the flight area, plus some tips for when your drone is in the air. We want to make sure you're ready to have fun collecting Spexi data and doing it safely. These short videos will help you have the best and safest experience on your fly-to-earn journey. Let's get started so you can get in the field and start smashing Spexigons. Before you gear up to fly, you'll want to make sure you're all set to do so. Most countries have regulation distinctions for operating small drones. That is, drones weighing less than 250 grams or about 0.55 pounds. If you're not sure what's needed to fly legally in your area, check out our resource linked to read up on your country's rules. If certification or licensing is required, make sure you have that in hand and follow all applicable rules before launching your drone through the Spexi platform. Something that may not be a legal requirement but will certainly be helpful is to add a list of checks or standard operating procedures. These should be convenient, helpful prompts to make sure you don't do something like leave the house for a flight without an SD card, or they might remind you to charge up and pack all your batteries. They can be as simple as a list on a piece of paper or in an app, but check out our recommendations too. Whatever you choose, just make sure it's something you'll use. Did you know that the leading cause of accidents in drone insurance claims is pilot error? Understanding yourself, your aircraft, and the limitations of both is critical to keeping the operation safe, so it's always good to do a little check-in before you fly. Are you sober, super stressed, tired, on any medications, anything that might make it hard to focus? Is it so cold you're finding it hard to move your fingers? Or is it so hot and sunny you're sweating and dehydrated? Taking a few moments before launching your drone can help you focus on what's important, improve your situational awareness, and reduce risk. You'll come to one of three conclusions. 1. You're good to fly. 2. You need to take a moment to eat, remove outside stressors, nap, or wait for the headache meds to kick in. 3. You gotta make the call to scrap the flight. In reality, that last one is going to be the hardest, smartest decision you can make because you'll never know if it was necessary. But your drone will live to fly another day, which is what we all want. It is never worth risking safety just to capture a Spexigon. There's not a lot in the way of maintenance you can perform on your drone, but there are some inspections and checks you can do to keep it in top shape. The moment you unpack your drone from the box, give it an inspection. Learn what normal looks like so you have a baseline to compare against if something cracks or gets loose. On these aircraft, most of the fun stuff is contained within the plastic shell, but you can check on motor security, the state of your propellers, gimbal stability, and look for hairline cracks that can sometimes form in the plastic even just with regular use, let alone a possible hard landing. Another critical component to monitor is batteries. These drones use lithium polymer or LiPo batteries. There's intense chemistry happening inside to produce power, so you want to be particularly cautious around batteries. Ensure you keep them in their temperature limits and regularly check cell health through the app. If they've been dropped in a crash, seem puffy or swollen, have trouble sliding in and out of the drone, or have some give to them when you squeeze, they may be unreliable at best and ready to start a fire at worst. And they contain everything they need for fire, except oxygen. So if that case breaks open, they'll burn until there is nothing left to burn. Now that I've sufficiently terrified you into keeping an eye on those batteries, it's helpful to note that they are smart batteries, meaning there's a computer attached that does its best to help you help them. This is what will give you cycle information and will intentionally discharge battery level when not in use to try to keep the chemistry at its happiest. Keep that in mind if you pack up fully charged batteries with a plan to use them in a couple weeks. They may have discharged on their own, so always double check before you head out. Give yourself time for this because there's always lots of battery levels to check on and charge up, including your mobile device, controller, and drone batteries. Next, we'll prepare our launch area. As tempting as it can be to arrive on site and begin unpacking your drone right away, there's a few checks we strongly recommend. First is weather. There aren't a ton of great resources to give really localized, low-level weather forecasts. We can do a decent job of forecasting based on what's around and what we're seeing, but specific sites might have some characteristics that create curveballs. The big things to look out for are the ones that your drone manufacturer has limitations for, specifically temperature, precipitation, and wind. Don't push these limits, they're published for a reason. If it's blustery at low level, like below the tree line or buildings, it'll be worse above. Look at trees for indications of wind changes. Smoke, flags, and even moving clouds can give you hints about wind, and sometimes your drone will even pop up with wind warnings, but by then it may be too late. High humidity and rain are a no-go for capturing Spexigons. Not only can they ruin the internal components of your drone without you even realizing there's an issue, but the imagery won't turn out well, so any data you risk your drone to capture becomes useless anyway. Second is bystanders. The main reason not to unpack your drone right away is to prevent the looky-loos from approaching to tell you what they think about drones. If possible, fly with a friend so the pilot can focus on what the drone is doing and the other person responds to interested bystanders. Minimize flight over people, particularly at altitudes that could be considered a nuisance. Generally, the higher you are, the quieter and less obtrusive you'll be. Third is other airspace users. The best way to scan the airspace around your flight area will be with your ears. Most times you'll hear approaching aircraft before you see them. If you could only see and not hear them, they likely aren't a concern. Tune your ears to listen for aircraft as soon as you arrive on site. It'll give you a good idea of how frequent traffic is in your area, regardless of how close you are to an airport. There are lots of aviation activities that happen outside of airport environments at low level, so being aware of and in tune with what's going on around you is key. If at any time you feel like they are getting too close for comfort, simply take back manual control of your drone and descend immediately. Better safe than sorry. On the remote control, you can pull the left stick directly down to start a descent, which will immediately pause the automated mission and return manual control. You can switch the mode on the controller to any other position than its current setting to pause the automated mission and return manual control. You can hit the return to home or RTH button on the controller, which will stop the automated mission and send the drone back to its takeoff location. To complete our site preparation, we need to check for obstacles. There are the obvious ones like buildings, trees, and other structures, and some that will add to this category that are a little more obscure, but still challenging to work around. Your drone operates on the same frequency band as a lot of other things. Popular things, like Wi-Fi, handheld radios, cordless phones, and even some signals sent on railway tracks. These, along with cell phone towers and high-voltage power lines, can cause interference, making your drone behave in unpredictable ways. Additionally, because it's so low to the ground when calibrating, metal structures and deposits can cause issues too, even underground ones like rebar in the concrete. You can always try recalibrating elsewhere for magnetic interference issues, but radio or electromagnetic interference can be a bit more widespread and harder to remove from your operating environment. Finally, take note of the sun's position when setting up your site. If you're staring at the sky, keeping your drone in visual line of sight as it captures the Spexigon, know that when you turn toward the sun on a day that's cloudless or even lightly overcast, it can be painful or impossible to try to keep the drone in sight. This might mean positioning to keep the sun at your back and to remember gear like a brimmed hat and sunglasses, even on winter days. Now that your site is safe to fly, let's review the launch procedure. Now that we've prepared our site, ourselves, and our drone, we're ready to take off and start collecting. Your launch area should be flat and free of obstacles both on the ground and in the air above it. We recommend that you launch the drone manually for each new flight. Ascend to between 5 and 10 feet to do a control check. Listen to your drone as the motors spin up and as it takes off and hovers. If all controls are responding normally, then begin the Spexi mission. The drone will ascend straight up to the height that the Spexigons will be collected at, typically 80 meters. At this point, we recommend pausing to complete a 360 rotation. This will allow you to verify using the camera that there are no obstacles taller than 80 meters in the vicinity. If something looks like it might be encroaching on your flight height, it's always best to double-check manually. If the skies are clear, then go ahead and start the mission. Once your drone is in flight, you aren't out of the woods. The next lesson covers some of what you'll need to look out for while the drone is in flight, and it's no time to get complacent. While the drone is in flight, you'll be using a few of your senses to scan the area, building situational awareness and monitoring the status of your drone and the surrounding area. Your ears will give you insight into bystander activity, other airspace users, proximity and movements of your drone, and even clue you into wind speed changes. Your eyes can also be scanning the area for people, aircraft, birds, and your drone. Your peripheral vision does a much better job than focused vision on picking up on movement. So if you lose sight of your drone, don't try to chase it around the sky with your eyes. Keep your head still and oriented in the general direction you know it to be, and let the movement be detected. If all the planning and prep goes as anticipated, this part will be the most boring in a good way. But if it's not, and you run into some abnormal scenarios, Here's some recommendations on how to address them. If there's a conflict in the airspace, for birds, climb. For airplane or helicopter, descend. For a conflict on the ground, if someone approaches you with an interest varying from curiosity to anger, it's best to deal with them when the drone is back on the ground. You can say something like, "I understand you wish to speak to me about the drone flying. It's unsafe for me to talk with you while the drone is in the air. Please allow me space and focus to land and secure the drone, and then I will speak with you." Even better is if you have a friend with you who can deliver that message and keep them at bay until you're able to join the conversation. And that's a wrap. Great work. We tried to make flying with Spexi easy and fun. And most of all, we want it to be safe for our pilots and the public. We're excited for you to get out in your neighborhood and smash some Spexigons.